good morning, ladies and gents. This is our week number 9. And you guys are hopefully really coming, maybe another week even. Grade 12s are here now, and the school's definitely picking up some energy. So today we're going to talk about limits and continuity and discontinuity. Okay, so that's what we're dealing with in these two lessons really for this week. We're going to start with limits. Okay? And by the way, just to let you know, now we are officially in calculus territory. This is proper calculus now. So let's take a function, a very simple function. F of x equal x plus 1. It's a straight line. Okay? Gradient is 1. Y-intercept is 1. Okay? And let's look at the specific point. Okay? Let's look at what happens when x equal 1. In other words, f of 1. Okay? So obviously it's 1 plus 1 equal 2. Okay? So we've got that coordinate. This line goes straight to this coordinate, which is 1, 2. Okay? Now I'm going to ask like a funny kind of question. Okay? Let me just write first. Okay? So I'm going to ask, not what's the value of the function at x equal 1, but what does the value of the function approach when we, or what is the value of the function when we approach x equal 1 from the right? So let's start, let's say with 2. Okay? If I say x equal 2, f of 2 is 2 plus 1 is 3. Right? Now let's get a bit closer to 1. Okay? F of 1 comma 5. That's going to be 2 comma 5. Okay? F of 1 comma 1. 1 comma 1 plus 1 is 2 comma 1. Okay? I'm just adding 1, yeah? F of 1 comma 0, 0, 0, 0, 1. It will be 2 comma 0, 0, 0, 0, or 0, and a 1. So, what I'm gaining, where am I going with this? The limit of the function, I'm explaining what limit is. The limit of the function, when x approaches 1 from the right, that plus means that I'm moving from the right, because we're going to move from the left in a minute. So as I'm moving from the right, from 2 to 1.5, 1.1, 1.001, okay, the limit of the function is slightly black, organized here. The limit of the function is 2. Okay, you can see I'm getting closer and closer to 2. As I'm getting closer and closer to 1, I'm getting closer and closer to 2. That makes sense. I know you're thinking like, why are we doing this? But you will see. You will see. Now, this is the limit of the function as I approach 1 from the right. That's a plus signing. Okay? I'll write that. We're approaching from the right. Okay? Now, might as well do the same thing, but now I'm approaching from the left. So we're going to write that x approaches 1. We're still approaching 1, but now the minus sign, meaning we're approaching from the left. Okay? That's right. Red. So now we are approaching from left. Okay? Now what will be the value of the limit of the function when I approach from the left? Okay? Well, let's have a look. Let's go from 0. Okay, so I'm going from the left of 1. So f of 0, 0 plus 1 will be 1. F of 0, comma 5 will be 0, comma 5 plus 1 is going to be 1, comma 5. Okay? F of 0, comma 9, I'm getting closer to 1. It's going to be 1, comma 9. F of 0, comma 999 will be 1, comma 999. So you can see I'm still getting closer and closer and closer to 2. Correct. So we got the same limit. Now you think to yourself, Mr. Lisham, are you an idiot? Of course you're going to get to 2, because f of 1 is 2. So it doesn't matter where you're coming from. Okay, that's true for this function. We're going to see function where that's not the case. Okay? So what we found here is that the limits of the function, when we approach to 1 from the right, is equal to the limit of the function when we approach 1 from the left. When that is the case, if you don't mind, I'm just going to erase this. When that is the case, when the limit of the function does not depend which way am I coming from, then I can say, only then I can say that the function has the limit at x equal 1. So I'm ditching that plus and minus, because it doesn't matter if we're moving from the right to the left. We say that the function have a limit. Okay? There is a limit. Let's write that down. Okay? So when we have that, there is a limit. I'm not going to write it down. You don't need to write it. It's all written in the book. Okay? So when these two limits from either right or the left are there, therefore we have a limit. Okay? Now, more than that. Okay? In this case, we got that the limit was actually 2. I'm just going to erase this. We don't need that anymore. Okay? In this case, we didn't just see that the limit exists and it was the same from either side. We also saw that the limit was equal to actually the value of the function. Right? Because the value of the function in this case, f of 1, was actually 2. Okay? Right? So when the limit of the function is equal to the value of the function, okay, when that happens, when there is a limit of the function, and that function, the limit of the function equal to the value of the function, we just put f of 1 as 2, then we say the function is continuous. Okay? We say it's continuous. F is continuous. And I really need to be careful here, because I only already checked one point. Okay? In this case, it was at x equal 1. So we say f is continuous at 1. But obviously, you can imagine I would have done it for any x, it will be the same. So we really say that f is continuous for all x's. Okay? So let me just summarize up to here. You know how to find the limits from the left or the right. If the limits from the right and the left are the same, they are equal to each other, then we can say f of x has a limit at x equal 1. If these limits are not the same, as we will see in other examples, then we can't say that there is a limit, because obviously it depends from which side you're coming. But if the limits are the same, we say that there is a limit. Now, step up, if the limit is also equal to the value of the function, we're not just saying there's a limit, we're saying that f is continuous there. Okay? I'll pause here and make some space on the board. Okay, so you might have thought I'm completely nuts. What does it matter? Aren't all functions continuous? Well, it turns out not. Okay? So what I've done here, I took a very simple function, okay, f of x equal x plus 1, but I defined them like we did in, I think it was the last lesson, over different segments, different section. So for all x's apart from x equal 1, minus 1, 2, 1.9, 0.9999, for all values of x except for 1, it's as before, x plus 1, we just add 1. But if f of x equal x, if x equal 1, value of x equal 1, then the value of the function I'm saying is 1. Okay? Let's just try and draw that. Okay? So look, x plus 1 is basically a straight line, just as before, crossing the y-axis in 1. But there is a difference, isn't it? Because if x is equal 1, the y is 1. So I need to put a little dot here. When x equal 1, y is 1. It's not 2. Okay? So what I'm going to also do here, I'm going to take that point. There is a tiny little, I'll make it a little bit bigger so you can see it. Okay? When x equal 1, y is not, I'll just throw it a little bit to there. Okay? When x equal 1, the y is 1. It's not 2. So if I added that little dot here, I have to remove it from there. That white dot means there is no x equal 1 doesn't belong there. Okay? Now let's see, okay, let's see if this is continuous. Let's first of all ask ourselves, is there a limit as x approaches 1? And I'm not going to go through the whole thing. I think you can figure out there is a limit. There's definitely a limit. If I'm going from 2 getting closer to 1, okay, the answer will be 1 plus 1 will be 2. If I reach from the left, from x smaller than 1, okay, Then I'll get to 0.5, will give me 1.5, 0.9 will give me 1.9, 0.999 will give me 1.9999. It will, as I get to 1, as close as possible, not touch 1. That's what limit means. Meaning I'm getting as close to 1, but I'm not actually touching it. Okay? As close as possible. Okay? The limit will exist and it will be 1. It will be 2, sorry. Okay? And I'll just write it, it's going to be the same as the limit if I approach 1 from the 1 positive, or if I approach 1 from the negative side. Okay? So there is a limit. But is that limit equal to that function? Is the limit of f of x when x approaches 1, is it equal to f of 1? Okay? And the answer is no. Because the limit of f of x when x approaches 1 is 2. And f of 1, according to this definition, I know it's crazy definition, but we can do that definition. We had functions divide onto different areas of x. Okay? That's not the same. So it's not equal to that. It's not equal to that. When the limit exists, there is a limit, from both sides is the same, the limit exists, but it's not equal to the value of the function, okay? Then we say the function is discontinuous, okay? F of x is discontinuous, okay? There is a limit, okay? But it's not equal to the function. It's a discontinuous function, okay? And this is actually one specific kind of discontinuity, and it's a removable discontinuity. Removable discontinuity. I'm spelling it wrong. It's wrong, okay? Now I'll also change one little thing. We don't say that f of x is discontinuous. We just say that f of x is not continuous. Okay? Continuous. It's just the language. We don't say it's discontinuous. It's not continuous. Okay? And there is a discontinuity, and it's a removable discontinuity. I need to explain that, because we're going to see different discontinuity in the next lesson. What is removable discontinuity? Obviously, I'm bonker face here. Okay? Whoever made up, which I guess is me, whoever made up that function is bonker face. And why do you have to do that insane thing? I can remove this discontinuity very easily, isn't it? All I'm going to do is just erase that one. Okay? And just say f of x is always x plus 1. And on the graph, suddenly, ooh, he's going to jump up there. And then everyone's happy. Right? So that's why we call it removable discontinuity. Okay? We have a little bit of a jump. Okay? I'll just bring that back here. We have a little bit of a jump. That's how you can tell that there's a discontinuity. Continuous is like there's no jumps. Okay? You just walk, or you can walk like this, and you can walk like that. You can walk anywhere, but there's no jumps. Here we have like the point. Okay? It's a discontinuity, like a step. But I can very easily remove that discontinuity. It's just one little point. Just one little point. Okay? Okay, I'll pause here. I think I'll make a new movie because it's getting a little bit longer. So I'll see you in a bit.